Okay, in this video we're going to work on our checkpoints. So what I want to accomplish is I want the ability for the player to be able to spawn at a checkpoint, and I also want him to, when he reaches another checkpoint, to have his respawn location set to that particular checkpoint. So once he gets so far in the level, I want his respawn location to change. This is going to require a couple of things. First of all, it's going to require that we write code in our level manager to enumerate over all of the checkpoints and store them in an internal data structure. After that, the level manager is going to be responsible for tracking the location of the player on the x-axis to determine if he's managed to hit another checkpoint. Finally, we'll also have to work on the death of the player. In order to be able to properly test that checkpoints are indeed being hit, we need to be able to have the player die at some point. So we're going to be putting our insta-deaths together so that when the player hits one of these punji sticks, for example, he dies, and then he respawns back at the closest checkpoint that he's reached. Alrighty, so let's go ahead and start up by opening up Visual Studio and jumping over into our level manager. In the level manager, I'm going to create a couple of private fields. So let's start off with creating a private list of checkpoints called checkpoints. Of course, this is going to require that we bring in a using system collections generic at the top. So now that we have our checkpoints, we also need to keep track of the current, I'm going to call this current checkpoint index. We need to keep track of which checkpoint the player is currently at. In addition to all of that, I also want to create a public field. So I'll create a public checkpoint debug spawn. And the purpose of the debug spawn is that when we're testing our level, I want the player to spawn at or be able to spawn at certain points. So let's say, for example, that a level designer is working on the last half of a level. He should be able to set a property on the level manager to inform the level manager to spawn the player all the way at that other checkpoint so he can do his testing. I want to call it debug spawn, however, because I want this behavior to not exist when we build out the game into a standalone version. So we'll see how we can use conditional preprocessor directives to accomplish that. Okay, so let's move on to our awake method. Our awake method is simply going to say instance equals this. So when a level starts that has a level manager, we want to set the instance field, or the instance property rather, to the object that was instantiated. This means that the other users of our level manager can access the current level manager simply by doing level manager.instance, and they'll receive a reference to the instantiated level manager in the game. Next up, let's work on our start method. The first thing we need to do is say checkpoints equals find objects of type checkpoint. Note that this is find objects of type and not find object of type. I can't tell you how many bug reports, like people are like, oh, I typed the video or typed the code exactly as it appeared, but I'm still getting this error. Yeah, typically that's due when you're using a method like find object of type or get component. Usually that's due to using the wrong variation of it, and that variation is determined by the pluralization of object or component. However, that's not all we want to do. We want our checkpoints array to be a checkpoints collection to be ordered by the position of that checkpoint in the x-axis. We can do this simply by doing .order by t goes into t.transform .position .x .toList. This will also require us to bring in using system.link up at the top of the file. So now on line 3, we have using system.link. That gives us access to the order by method as well as the toList method. But now that we've done that, our checkpoints list now contains a sorted list of all the checkpoints in our scene without us having to manually go in and add it to an array on our game object. Then what I want to do is I want to say current checkpoint index equals, let's give it something like equals checkpoints.count is greater than 0, question mark 0, otherwise -1. What does this code do? Well, it says if there are more than 0 checkpoints, set the current checkpoint index to 0, and 0 being the first item in the collection. Otherwise, if there are no checkpoints in the scene, set the current checkpoint index to -1. That's a special flag that I'm going to be using throughout the level manager to determine that there are no checkpoints and we don't have to perform any checkpoint behavior. Alrighty, so now that we have that all set up, let's go ahead and finish our start method. So we're going to add some more stuff to our start method later down the road, but for now what I'm going to do is I'm going to cache our player. The way that I'm going to do that is I'm going to say find object of type, not find objects of type, player, and then I'm going to say camera equals find object of type, camera. So now we have our player and our camera cached locally on our level manager. Makes them a lot easier to locate. Also, it's not find object of type camera, it's find object of type camera controller. Sorry about that. Okay, so now we have our player and our camera set up. Again, we're going to be doing some additional logic later down the road. But right now what we have to do is we have to spawn the player. That's because wherever the player is located in the scene, so if I look in the scene, I see the player is located in the top left. I don't really want him to start there when I hit play, because if I have the player all the way over here, I really just want him to start at the level start. Level start happens to be the first checkpoint. So what I have to do is I have to find the first checkpoint, and then I have to tell it to spawn the player. However, this behavior will be modified by our debug spawn field. So let's see what it looks like with that. I'm going to say if debug spawn does not equal null, then debug spawn dot spawn player player. Otherwise, if current checkpoint index does not equal -1, then checkpoints at current checkpoint index dot spawn player player. All this code says is if we've set a debug spawn, then tell the debug spawn to spawn the player. Otherwise, set the current checkpoint, if this current checkpoint index is not -1, remember -1 is the flag to determine an invalid index in our checkpoints collection, then tell that checkpoint to spawn our player. But we only want this code to execute if we are in the editor. So we can use a cool little trick that will only have this code appear in our file if we're in the editor. We do that using preprocessor directives. I'm going to say #if space unity underscore editor. Then after this code, I'm going to say else. On the else clause, I'll write the code that I want to appear when we do a build. And the code that I want to appear when we do a build is if current checkpoint index does not equal -1, then checkpoints at current checkpoint index dot spawn player player. And then I'll end this with an end if. So what I have here is a conditional block of code. This code will be used when we're in the Unity editor and just designing our level, and this code will be used when we're working on a standalone player or an iOS build or an Android build or what have you. Okay, so what this code will do is this will have the player spawn at either the debug spawn or the first checkpoint. Let's go ahead and test that. I'm going to fire up Unity again, and I'm going to move the player all the way. Let's move the player all the way over here, and let's hit play, and let's see what happens. Well, didn't quite work out the way I wanted it to. So let's go ahead and check to see what's going on here. We have the level manager script added to our level, and we have the player right there. So let's jump back into Visual Studio and see what could have gone wrong. Our level manager is a mono behavior, and in our start method, we find all the checkpoints in the scene, which we have checkpoints. We can see that by looking at these game objects and noticing that they have the checkpoint component attached to them. And we order by the position X and do .toList. We set the current checkpoint index to checkpoints.count is greater than 0, otherwise 1, or -1. We get the player and we get the camera. Oh, I actually know what's wrong. We never implemented the spawn player. Wow. See, that's the problem about stubbing out the code first and then implementing it, is sometimes you forget that those public methods that you've written weren't actually implemented. So spawn player actually does nothing. And we're going to keep it like that for now. And the reason is I tried to jump around in code as little as possible. So we'll implement the spawn player method here shortly after we finish all of the bits in the level manager that we want to do. So the next method on our list in our level manager is going to be our update method. So what I want to do is first determine if the player is at the last checkpoint. So I'm going to say var is at last checkpoint equals current checkpoint index plus 1 is greater or equal to checkpoints.count. This will result in a boolean that will indicate if we are on the last checkpoint or not. If we are at the last checkpoint, we have nothing to do here. There's nothing left to do in the update method of our level manager because remember the level manager is going to be responsible for telling the player that he's passed a certain checkpoint. So I'll just say return. Then I'm going to say var distance to next checkpoint equals checkpoints at current checkpoint index plus 1 dot transform dot position dot x minus player transform position x. Distance to next checkpoint will be a number that indicates how far away on the x-axis our player is from the next checkpoint. We're going to say if distance to next checkpoint is greater than 0, return. So if we're like, or let's just say greater or equal to, why not? That just says if we haven't hit the next checkpoint yet, meaning the distance next checkpoint is greater than 0, then we'll just early exit out of the method because we had nothing else to do. Finally, if we get to line 52, that means we've hit a new checkpoint. So what do? We say checkpoints at current checkpoint index. So we'll pass in our current checkpoint index, and then we'll say player left checkpoint. And that means that the player has left that checkpoint or the current checkpoint that he's at. Then I'll say current checkpoint index plus plus. Then I'll say checkpoints at current checkpoint index, which is a new current checkpoint index because we've incremented it, dot player hit checkpoint. Then I'm going to say game, we won't do that quite yet. We're going to leave this, we're going to say to do time bonus. So after we've done that whole thing, we've told the player that he's now at a new checkpoint, we will just work on our time bonus, which we haven't implemented yet. Okay, the last thing we have to do for now in our level manager is write the kill player and the player kill player co methods. The kill player is simply going to say start coroutine, and it's going to pass in the result of invoking kill player co. Now, start coroutine is a Unity method that will allow a method's execution to span multiple frames. So what can we do there? Well, the behavior that I want when a player dies is I want to say player.kill. That'll tell the player that he's dead. I want to set camera.isFollowing to false. I want to yield return wait for seconds. Let's say 2 seconds. So that means we're yielding execution back into Unity for 2 seconds. Then I want to go ahead and say something like camera.isFollowing is true. And the final thing I want to do is check to see if the current checkpoint index does not equal -1. If it doesn't equal -1, then checkpoints at current checkpoint index.spawn player. So that'll tell the checkpoint to spawn the player. So again, we kill the player, we set the camera is following to false, we wait for 2 seconds, we set the camera is following to true. We then check to see if we're at a valid checkpoint. If we are, we tell that checkpoint to spawn the player. We're also going to do some additional stuff here. So we'll say to do, and then we're going to work on our points. So this is some additional code that we're going to write in a later video when we implement our points. Anyway, so that pretty much takes care of what we need our level manager to do. So next up, let's work on our checkpoint. So our checkpoint is responsible for knowing when a player left a checkpoint, knowing when a player hit a checkpoint, and knowing when a checkpoint needs to spawn a player. Those are its responsibilities. So let's jump over into our checkpoint file and work on some of these methods. We're not going to need all of these methods implemented quite yet. We will be working on them in the future. So let's just start and deal with the ones that we do need to worry about. And in this case, we just need to worry about spawn player. Spawn player is simply going to say player.respawn at transform. So we're telling the player to respawn at the transform of the checkpoint. And then in reality, that's all we need to do on the checkpoint. Yeah, you'll notice a lot of empty methods here, but this is some stuff that we are going to have to implement in a later video when we try to implement some of our features. But for now, the only thing that the checkpoint really needs to do is tell the player to respawn at a particular location. Now that we've done that, we can go into the player class and actually work on the kill and the respawn at methods. So jumping into player, we see that we have two unimplemented methods, kill and respawn at. Let's go ahead and implement them. The kill method is really not going to do much except for set his controller to handle collisions equals false, and then set his collider 2D.enabled equals false. Setting the handle collisions on the controller will make the player fall through the world. And then setting our collider 2D to enabled false will make it so that we don't cause any triggers to happen during that time. Okay, in addition, I also want to set a property called isDead, and I want to set that property to true. Now we haven't implemented that property yet, but we will here in a moment. Now let's go ahead and do the respawn at. What's respawn at going to do? Well, first of all, it's going to have the player flip to the right. So I'm going to say if not is facing right, flip. So this will flip the player to the right. Then I want to go ahead and set is dead to false, because he's no longer dead. Then I want to set his collider.2D.enabled to true, enabling his collider. I want to set his controller handle collisions to equal true. And the final thing that I want to do is say transform.position equals spawn point.position. So the respawn at method will make sure he's now set to alive. It'll tell his controller to handle collisions. It'll enable his collider 2D, and it'll move the player to whatever position that was specified. Okay, let's go ahead and add the isDead property. So I'm going to come up here to the top, and I'm going to say public boolean isDead get private set. Okay, so now that we've set the isDead to something true or false, there's some additional logic that we need to perform. In particularly, we have to know if the player or if the player is dead to determine whether or not we need to handle our input. So instead of just writing handle input up in our update method, I'm going to say if not is dead, and then I'm going to say handle input. So by doing that, we now say that input will not be handled if the player is dead, making it so we can't move him, we can't fire anything, we can't jump, we can't do anything like that. Okay, the last thing that I want to do in the code for this video is write our instakill method. Our instakill method is going to be very straightforward. So I'm going to go up here to code, and I'm going to add a new class, and I'm going to call it instakill. I'm going to remove the namespace definition. Then I'm going to have it inherit from mono behavior. And now we have a mono behavior with Unity Engine being imported at the top. This class will be very simple. It'll simply say public void on trigger enter 2D collider 2D other. Now what does this code have to do? Well, all it has to do is it has to detect if it was a player that hit it. If it was a player that hit it, we'll kill the player. So I'm going to say var player equals other.getComponent of player. Then I'm going to say if player equals null, return. Otherwise, level manager dot instance kill player. So the insta-kill will check to see if it collided with the player. If it did, it'll invoke the kill player method on our level manager. Okay, let's go ahead and jump into Unity, and I'm going to modify the level a little bit. First of all, my punji sticks, this prefab right here, I'm going to come over here to add component, and I'm going to type in insta-kill. And this will bring the insta-kill component onto our punji sticks. Then I'm going to hit apply. What that'll do is that'll make it so whenever the player hits the punji sticks, he dies. The next thing I want to do is I want to replace two of these tiles. So I want to replace this tile and let's say this tile with punji sticks so we can check to see that our checkpoints are working. So I'm going to click on this tile and I'm going to delete it. Then I'm going to click on the punji sticks and hit Control D to duplicate it, and then hold down Control and snap it right into place right there. I'm going to do the same thing over here. I'm going to delete one of these tiles. I'm going to grab my punji sticks, hit Control D, and move it all the way there to the right. Now that we've done that, we should be able to test our level manager. So let's go ahead and hit play. And you'll notice that what we get is an exception. So the player indeed did not get moved over to the spawn point, and also we got an error. And the error said that object reference not set to an instance of an object. So let's open up Visual Studio and track that down. Opening up our Stack Trace Explorer, we see that we are having an error right here on player.cs line 35. It says controller.handleCollisions equals true at respawn at. Okay, so this issue might look very complicated, but in fact it's not. What we have here is a case of not really a race condition, but an instance where the choice of awake and start matter significantly. You'll notice that the controller2d.handleCollisions true isn't being invoked. Why is it being invoked? Well, it's being invoked because respawn at is being invoked. Who invokes respawn at? Well, you can see that the checkpoint invokes respawn at. Who invokes spawn player at the start of the level? Well, we can see that the level manager will invoke spawn player at the start of the level. But you'll notice something interesting. This method is the start method of the level manager. If we move over to player, we'll see that the controller is not assigned to a value until the player's start method is invoked. What's going on is the start method of the level manager is happening before the start method of the player, meaning that our controller is null, therefore the respawn at method will throw an exception. To fix this, we can simply type in awake here instead of start. Awake will always happen before the start methods. Awake happens when the component is created, whereas the start method will be handled when after the object is totally initialized. So in theory, this should work. Let's go ahead and open up Unity and hit start. And you see, we indeed spawn all the way here on the left-hand side of the map, and we don't get an error. So let's go ahead and test our insta-deaths. Indeed, it worked. You'll notice that I died, I fell down, my input stopped working, and then I respawned 2 seconds later. Okay, so now that we've done that, let's move over to another checkpoint. Oh my, wow, I made this game too hard. Oh, here we go. I hit the other checkpoint, fortunately. So now we're at the second checkpoint. Let's go ahead and die. I'll kill myself over here on this guy, but I should still respawn over here on the right. And indeed I do. And then if I kill myself on those spikes, I respawn over here. Okay, by this point I should have hit the other checkpoint. So let's go ahead and kill ourselves. And see that in 2 seconds we do indeed spawn at the correct point. So our checkpoints are working. Let's go ahead and, so we have our checkpoint 1 and our checkpoint 2. I did notice potentially that Oh, I know what happened. Okay, what we want to do is when we die, I want the player to kind of jump up a little bit, and then I also want him to have no more velocity in the X direction. So let's go ahead and fix that. To fix the first problem of the player moving after he dies in the X direction, we can simply go back into our player script, locate his update method, and notice what we have here with set horizontal force. Now, I could certainly turn this into a ternary, but to make this code a little bit more clear, I'm going to use a straight up if statement. I'm going to say if is dead controller.set horizontal force 0. Otherwise, set horizontal force to mathflerp. And then I'm going to tell ReSharper to ignore that warning because I'm doing that. I'm not using a ternary on purpose in this particular example to make the code a little bit more clear for people who might not be so familiar with ternaries. Okay, now that I've done that, I also want to apply some vertical force when he does die. So I'm going to scroll down to my kill method, and I'm going to go down to the bottom of it, and I'm going to say controller dot, let's do a set force. I'm passing 0, and then I'm going to pass in, I don't know, 20. All right, now if I come back into Unity and hit play, and jump on one of these punji sticks, you see I jump up, I fall down off the screen, and then I respawn. And I think that's a fairly acceptable method of death. I mean, what do you think, Steve?
Yeah, very much so.
All right, sweet. And you notice when I die, I can no longer move, and my X velocity is reset to 0, which is exactly what I want. All right, I think that pretty much does everything I want it to. I mean, we talked about getting our checkpoints working. Our checkpoints do indeed work now, which is really cool. And our players capable of dying. So, yeah, I think in the next video, we're going to go ahead and take a look at points. Because like I said earlier, I want the checkpoints to give a time bonus for the player if he can get from one checkpoint to another in a certain amount of time, adding an actual game mechanic to this game that isn't really a game. So, I guess we'll see you guys in the next video.
All right.